You know, one of the most visually mind-blowing demonstrations that I've seen in physics is actually quantum levitation. I'm going to explain what it means. I'm going to explain how it works. It's a very interesting and mind-blowing visual demonstrations in physics. So we have materials, right, according to their level of electrical conductivity. We have insulators, we have conductors, we have semiconductors, and we also have another material that is called superconductors. So superconductors are actually materials that when they get cooled below a particular critical temperature, they begin to have zero resistance, like zero resistance. Yeah, and superconductors also have a phenomenon that is called the Meissner effect. What is the Meissner effect? Meissner effect is that superconductors, they repel magnetic fields completely. Like they don't, once they feel the effect of magnetic field, they repel it completely. So this is what happens. So when you place a superconductor on top of a magnet, once they feel the magnetic field energy, they get locked in and they begin to float on top of the magnet. Very, very interesting concept, right? So, and the kind of floating that these superconductors do on top of magnets is that they don't slide. You know, usually, I know you must have tried this thing before, where you bring maybe two sides of a magnet, the south and the north pole, when you want to bring them together, and then you begin to feel the repulsion and they begin to slide and slide. When a superconductor is placed on top of a magnet, it gets locked in. It gets literally locked in. It's not moving and it begins to float, right? That effect is called reflux spinning. Actually, it's called reflux spinning. So what it means is that the superconductor, it traps the electrical field lines. It traps it inside itself so that it can stay locked in. And you know, the very, very interesting thing about this is that a superconductor can float on top of the magnet. It can float beneath the magnet, and it can also float sideways of the magnet. Very, very interesting. And the reason why I can do that is because I said earlier that the superconductor actually traps the electrical field lines inside itself. So, and that causes it to lock in, right? So which means that it can float beneath it, and it can also float sideways without sliding. So, and what that also tells us is that if after the superconductor gets locked in and is already floating on top of the magnet, you can actually place materials, weights, objects, you can place them on top of the superconductor while it is floating, and those objects will not fall. Like, it's mind-blowing, like literally mind-blowing. It's called quantum levitation. You can also try it out, right? You can try it out, and you can actually send a DM. I can send you the kits to actually try it out. So and one of the agents that can actually cause the superconductor to cool below its critical temperature is liquid nitrogen. I know, in case you don't know, or in case you actually know, liquid nitrogen can help you cool the superconductor below its critical temperature, and then you can demonstrate it.